Let's look at fractions now in a different way. It's something called equivalent fractions. Here is a bar of length 1. Underneath, I've cut a bar into half. Underneath that, I'm going to cut a bar into quarters. Underneath that, I'm going to cut a bar into eighths. Now, I can see that a half is equal to a number of quarters. How many quarters is it? A half is the same length as 2 quarters. These fractions are equal in size. We call them equivalent. I can also spot though that 1, 2, 3, 4 eighths is also equal to a half. So 1/2 equals 2 quarters equals 4 eighths. These are all equivalent. That means they are the same size. The question is, are there any others we can see on this diagram? Pause the video now and spend a couple of minutes looking to see if you can spot any more. Hopefully now you've unpaused the video and found some of the following. That 1/4 equals 2 eighths. That 3/4 equals 6 eighths. Some of you will have said that 2/2 equals 4 quarters, which is equal to 8 eighths. And all of those are equal to 1 whole, because the denominator, the number of pieces you need to make a whole one, is matched by the numerator. Well done if you spotted those. I wonder if you can also come up with some other equivalent fractions of your own. Let's use these 3 to try and come up with some more. Can you give me one more equivalent fraction? I bet you can. I think lots of you will have said that. Let's have a look at if that's true. Let's use a diagram to explain. There is my whole one, cut into half. There it is, cut into quarters. There it is, cut into eighths. Each time I'm chopping up each piece and getting 2 pieces from it. So now when I go to 16, let's do that again separately. 1/2. There is a half. Now it's cut into, that's right, 2/4. When I cut it again, it's now 4/8. When I cut each of those pieces up, I now get 16 pieces in total. So, you can find an equivalent fraction quite easily so far. You might even be able to work out what the next one in this sequence is. That's right, 16/32, well done. And the next one? 32/64. Well done. Let's try this one. Can you come up with an equivalent fraction? Well, so far, we've had a rule that links all of our equivalent fractions together. I wonder what you're going to say is the one that is equivalent, using this number pattern. There are 2 very good answers here, based on this sequence. One of those is 2/6. Can you see why? Another one would be 3/9. Can you see why? Let's draw it out to help. Here is our whole one, cut into thirds. If I cut each piece in half again, what was originally 1/3 is now 2/6. What about 3/9? How did they get that answer? There's 1/3. Well, what did I do there? I chopped each piece into 3. 1, 2, 3 pieces now are shaded out of 1, 2, 3, 4, 5, 6, 7, 8, 9. Some of you very correctly spotted that up here we were doubling to make the next equivalent fraction. But actually, you can see here, it's not always doubling. In this case, it's timesing by, that's right, by 3. Now, do certain rules work for certain fractions and not for others? Let's have a look. Let's start with a half. And let's say, can we multiply both bits by any number? Let's pick 5. So here is a half. I'm going to cut that into 5 pieces. I'm going to cut the other half into 5 pieces. How many pieces have I now got shaded? That's right. Out of how many? Good. So, I can create an equivalent fraction by timesing both parts by any number. Let's check one more. 3/4. There it is. I'm going to chop that into something out of 24. What did I multiply by? I multiplied by 6. So I'm chopping each piece into 6. So how many pieces are now shaded? There are 6 here, 6 here, and 6 here, which makes 18. So we have got now ourselves a rule for equivalent fractions that we will write down in part 2.